Welcome to the EDM Online Continuing Education video series from the Elevator Educators YouTube channel. This video series will cover a wide range of topics on elevating devices. These videos are unlisted on the Elevator Educators YouTube channel, but are provided to elevating device industry personnel registered on our email list. These videos are complementary to our EDM Online Continuing Education programs you have attended in the past. Thanks for viewing the videos, and comments can be sent to training@elevatoreducators.com. Please note this disclaimer regarding the following tutorial. The information in this continuing education series is not specific to any equipment and is generic in nature and shall only be used for educational purposes. Always follow the regulations, elevating device codes, and safety codes adopted in your jurisdiction. The information in this continuing education series should only be used in field applications when accepted as part of your company policies and procedures for installation, service, and maintenance of equipment. We accept no responsibility for the use of this information for any purpose. Welcome to the continuing education series for elevating device mechanics, brought to you by elevatoreducators.com. In this tutorial series, we'll be discussing elevator hoist ropes. Can you answer the following questions, true or false? An 8x19 seal construction rope has 171 wires that comprise the moving parts of the rope, true or false? The Brinell hardness of an elevator traction sheave is always a greater Brinell hardness than the elevator traction rope, true or false? Elevator hoist rope's lubrication is more dependent on the time frame between oiling and oiling the rope when dry than the number of start cycles of the traction equipment, true or false? Lack of equal rope tension can lead to a reduction in hoist rope life at a maximum of 30%, true or false? When you install new hoist ropes on an existing machine sheave, you can expect the new ropes to always last as long as the last set of ropes, true or false? We will be discussing all these questions in this tutorial series. Number 1. 8x19 seal construction ropes have 171 wires that comprise the moving parts of the rope. False. Hoist ropes are not merely a random wrap-grab bag of stranded wires. They are precisely engineered, surprisingly complex objects made of soft steel offering a number of moving parts. Take, for example, an 8x19 seal hoist rope. It has 152 separate moving parts, 8 strands, 19 wires per strand. In addition to being crafted to be both strong and durable, elevator ropes must be designed to be flexible as well. Normally, these are mutually exclusive goals. Rarely is any item created to provide strength required to be able to bend with the same level of proficiency as well. Normally, higher strength means higher rigidity. Ropes are classified by the number of strands as well as the number of wires in each strand. For example, an 8x19 seal rope has 8 outer strands, with each strand containing 19 wires. The core's most important job is to provide support for the strands. Valley breakage is directly related to the support provided by the core. Lack of proper lubrication is the most common cause of core failure. Question number 2. The Brinell hardness of an elevator traction sheave is always greater than the Brinell hardness of an elevator traction rope. This is false. Traction grade elevator wire is approximately 165% harder than the sheaves. Extra high strength traction wire is approximately 200% harder than the sheaves. Wire rope is harder than the sheaves on which it operates. Therefore, the sheave will continually wear throughout its life. Figure 2 shows the progression of sheave wear. As the rope operates, it seats itself into the groove, causing a diameter reduction in the sheave as the sheave is worn to match the diameter of the rope due to the greater hardness of the rope. The resultant worn groove now will adversely affect the performance of each new rope if installed. If any rope shows sign of abrasion, it is an indication that the sheave groove is wearing as well. Wire rope is subject to radial pressures by its contact with the sheave. The pressures set up shearing stresses in the wires tend to distort the rope structure and affects the rate of wear of the sheave grooves. The speed of the car, acceleration and deceleration in shorter periods of time, combined with the effects of slippage and creepage, higher groove pressures, and smaller sheave diameters results in sheave wear that is faster. The undercut U and V grooves add to the increased pressures placed upon the sheaves and the ropes. Shown in Figure 4, the rope's contact points are evenly spread throughout the U groove. However, the points of contact are reduced in the V groove, where the sheave and the rope wear are exponentially increased. If any rope shows signs of abrasion, it is an indication that the sheave groove is wearing as well. The following are some of the references that were used to prepare this tutorial. Please review them for more information on hoist rope maintenance, inspection, and technical information. Thanks for watching, and see you next video.